Hey guys, my name is Jason with Mount Baker Mining and Metals, and on today's video I wanted to kind of follow up on a video that I did earlier, kind of a production smelting video I did earlier about maximizing the amount of sulfides and concentrates you could fit into your crucible for smelting. And now I wanted to tweak the flux recipe a little bit to try and maximize the amount of metals we can recover from our production smelts. All right, so here's what we're going to be doing. We're going to take probably 5 different samples of those sulfides. I've got them mixed up here with our first flux recipe. This is 100 grams of sulfides, 100 grams of anhydrous borax, 25 grams of litharge, and 25 grams of potassium nitrate as an oxidizer. I'm going to put them in this number 4 crucible here. I'm going to add an iron rod to help reduce some of those sulfides to iron sulfide. And I'm going to measure the size of the lead button that we recover based on varying the amounts of borax and soda ash. So this first one is going to be all borax. Then I'm going to slowly reduce the borax and replace it with soda ash until we get all the way to the end member of 100 grams of soda ash and no borax. And we'll see if that affects the amount of lead we recover. And then I will cupel all the lead buttons and we'll see the size of the precious metal beads we get at the end. And we can compare the recovery based on the amount of borax and soda ash in our recipe. And here's our last pour after it's cooled down in the cone mold. This is the 100% soda ash. And you can see it's just all rusty and just looks nasty. So I wanted to show you guys that before I knocked it out of there. But let's get it knocked out of there and we'll compare it to the other 4 samples we did. All right, guys, so here's our 5 samples all laid out. And we've got this one on the end is the 100% borax. This one is 25 grams of soda ash, 75 grams of borax, 50 grams of each, 75 grams of soda, and 25 grams of borax. And then this one is all soda ash. And you can see this one's cooled down a bit, and you can see this is actually all matte here. And there's a little tiny lead button right on top there. And I expect that as we go down the line here, you're going to get less and less matte, and probably somewhere in here, you're going to have no matte at all, and then a big lead button. But let's get these cooled down a little bit, and we'll break them open, and we'll kind of see what we got, and then we can cupel them and figure out how much precious metals we recovered from each sample. And here's our sample from the 100% borax, and our lead and matte end up being a little over 100 grams. Here's our sample with 25 grams of soda and 75 grams of borax. and the lead and matte end up being 92 3/4 grams. All right, so let's do a drive-by of our slag here. So this is the borax. Here it is. And it's super glassy, and it had all that matte. You can see there, it looks like obsidian. Here's the one with a little bit of soda ash, 25 grams of soda. And it's not as glassy, but you can still see it fractures kind of glassy, and it has that conchoidal fracture still. Here's the matte, and this is where it starts getting kind of interesting. This is, or not the matte, the slag, that has 50-50 soda and borax. And it looks like there's kind of matte crystals kind of halfway dissolved in the slag, but they're not all the way dissolved. They're kind of interdispersed through that lower half of the slag there. And then now we're up into the 75 grams of soda, and you can see there's not really any matte crystals anymore, and it's really kind of dark gray, dull color. I think the term might be stony. And the matte's pretty much gone away. There wasn't any matte with the lead button. And then this one might still be kind of hot. This is our 100% soda ash, and there's no matte at all. It actually, you can smell the sulfur on it. But this was kind of the interesting thing. The lead button was right here, and the lead button separated really, really well from the slag. But there's what the 5 different slags look like. Now let's go take a look at our lead buttons and see what those look like. Okay, I'll just throw these up here real quick and go through them. Here's the borax one, about 7 grams of lead. Here is 25% soda, 75% borax, 11 grams of lead there. Here's the 50-50. Oh, interesting, less. 8.5 grams. Here's the 75% soda, 25% borax, 14.5. And here is 100% soda. 12.5. All right, now a couple things here before I forget. We'll cupel all of these, but when you're smelting, a couple of things I learned is, especially when you're over here using 100% soda ash or more soda ash, you want to heat it up slower, and you do not want to get it past about 2,000 or 2,100 degrees, because if you start seeing a yellow flame kind of coming off your crucible, something is happening there. You might be oxidizing the sodium there. And if you let that go too long, it looks like what happens is iron metal gets reduced in your pot. And when you go to pour, it's all this kind of slushy iron mixed up junk. So you don't want to get it too hot where you see that yellow flame. And if you heat it up too fast, it tends to boil over and bubble a lot. So those are important things to know there. Also, there are a couple different types of crucibles. This is a clay graphite crucible. This is the one I was using today. And this is a fire clay crucible. And if you're going to use really basic slag or fluxes, basic being, a really high pH, such as soda, you really need to stay away from the fire clay, because the soda ash will eat the silica up in this really, really fast, and you'll have crucible failing on you left and right. So I like to use the clay graphite crucibles or the silicon carbide crucibles when I'm using really, really basic fluxes. Also, with these lead buttons, I tried to keep the retention time in the furnace about the same across all of these. Once they were molten and up to temperature in the furnace, I let them cook for about 5 minutes. And so there may be a little bit of variation here in the weights, just because I'm running around trying to do a bunch of stuff all at once. And so there may be a little bit more retention time from one versus the other, but I tried to keep it as consistent as I could for this test. So that could be something else that we test for in the future, is the same flux recipe somewhere over on the basic end of the spectrum, but you leave it in, maybe 5 minutes one smelt, 20 minutes the next, and 60 minutes the next, and see if you can get more recovery that way. All right, we got our lead in our cupels. I'm going to put them in the furnace and cupel the lead away, and we'll get our precious metal buttons. We'll get them weighed and see which one of these had the best recoveries. All right, guys, so here's our 5 samples. This one over here on the right is the 100% borax, and moving to the left to 100% soda ash. And interestingly enough, most of these beads are about the same size. I thought we were going to have, very little or hardly any bead here, and then increasingly larger beads as you go across, but visually, they're all about the same size. So let me pull them out. I'll weigh them, and I'll tally up kind of the results, and we'll take a look at those. All right, guys, before we take a look at the weights, I just wanted to show you this. This bead in the right here is from the 100% borax, and it is much more yellow than this bead on the left, which is from, I think, the 75% soda and 25% borax. And so it might be one of the side effects here is when you have matte or the more acidic flux, you recover less silver because this one's more gold colored, and the more basic you make it or the less matte you have, you recover more of the silver. So that's just kind of a little side note I wanted to share. While I was weighing these, I noticed that little visual indication there that this one has more gold color to it than that one. All right, and here's our results. I'm not going to go over all these, but you guys can pause and take a look and really dig into it. Here's the recipe we use for the flux. Here's the weight of the lead buttons, and here's the weight of the bead in precious metals. Now, interestingly enough, the highest weighted button wasn't an end member of either one. I thought the more soda you had, the more recovery you were going to get. It was actually, looks like it's more based on the size of the lead buttons. So the larger lead buttons ended up with more precious metals, and the ones that weighed less ended up with less precious metals. So that was interesting. So now that the next experiment I want to do is based on time, leaving the crucibles in for a longer amount of time and letting them work on that iron a little bit more, hopefully reducing more lead and recovering more of those precious metals. All right, guys, for our next little experiment, we're going to do some smelting based on time. And so I have, these are all the same, 1, 2, and 3. These all have the same recipe that got us the largest precious metal button on our first set of experiments. So it's at 75% soda and 25% borax. I'm going to put them all in the furnace at the same time, and I'm going to heat them up for different amounts of time. So this one I'm going to pull out and pour after 5 minutes after it's been molten. This one I'll pour after 30 minutes of being molten, and this one I'll let go for an hour after it's completely molten. And then this one, just out of curiosity, I'm going to do one kind of that other end member with all the borax that we didn't necessarily get the largest button from, but I want to see if we have a real acidic flux and let it go for a long time. I'm going to leave this in for an hour as well. If we can actually recover more lead and more precious metals with a really acidic flux. So we'll get these loaded in the furnace, get them molten. I'll time them, pour them, and show you the results. All right, there's our 4 samples in. I tried to keep them away from the direct flame contact. This is where the flame's going to come out. And so we've got our 3 soda samples with a little bit of borax, and then this one's our borax sample here, and I'll let that one stay in for an hour. All right, guys, so some really interesting stuff I wanted to show you. First, we'll look at the iron bars here. These are the ones that were submerged in the crucible, acting as our source of iron. And these first three here are the ones that were in the soda borax mixture. And they're all eaten about the same from here down. I've kind of knocked some of the slag off so you can see it better, but it didn't eat a lot of the iron, and it ate about the same no matter how long they were in for. This one was the borax one, and it's still a little hot. But this one got eaten a lot, both right at the surface where the iron bar went down into the slag, and then also down here where I believe it was sitting in the mat while it was molten. And there's this little kind of stub here, probably where it was sitting in the pool of lead and protected. But this one surprisingly got eaten the most out of all three. So that was an unexpected result. Now we'll take a look at our slag here. This stuff is cooled down, so it broke up. This is still really hot, and this is the borax one. But this was the one I poured after about 5 to maybe 7 minutes. And it hadn't boiled. I think I got it on video there about 20 minutes into the melt. These last two boiled and foamed up, and they were sparking and yellow flames coming off and stuff. This one did not. And I weighed this slag. This weighs 250 grams. This was surprisingly a lot less in volume. The pyramid shape was a lot smaller, and this only weighs 175 grams. So through that boiling process, I lost 75 grams of stuff somewhere. Also, if we can take a look here, it looks like this has become more acidic. This looks a lot more like our 50-50 borax soda mix, where you can kind of see the mat is like little matte crystals in there, where the mat's showing up in the slag a little bit. It's not totally dissolved. Like here you can see it's still totally dissolved. There's no iron looking crystals at all. It's just all black matte. So it's almost like the soda or some of the sodium in there burned off maybe. I'm not quite sure what happened there. I'm waiting for this one to cool down, and I'll break that one up because this one was in the longest. But when it started boiling and foaming, I switched it over. I like to run a little bit of an oxidizing flame, so a little bit more oxygen. And I switched that back over when it started burning, essentially, and started running a slightly reducing flame. And you can tell it's reducing when you get a little bit of flames coming out of the top of your furnace. That means the propane's not getting burned up until it leaves the furnace. And so inside the furnace, there's no oxygen, which if the soda is burning up, if that's what our problem is, running a reducing flame may help that because there's no oxygen for whatever it is, the soda, to react with. So I'm going to let these two cool down a little bit more, and then we'll break them up, and we'll take a look at the lead beads. All right, guys, so here we're looking at the mat from our borax sample that was in for 60 minutes. And this mat is hard. It's super hard. And interestingly enough, at the tip, there's no lead at all. So we didn't recover any lead button on this one. So this is pretty much a total failure. Okay, and here's our 3 lead buttons that we ended up with. The first one at 5 minutes weighed 17 1/3 grams or so, which is surprising because this is the highest weight we got out of any of our buttons from the previous experiments, and we pretty much ran the same conditions. Here's another one. After 30, we got 13.45, and then the 60-minute one, which actually ended up being our largest button, was 18.36 grams of lead, and then the borax one, we didn't get any lead. So the real question is going to be which one of these has the most precious metals. So let's get these in the cupel furnace and see how big our precious metal beads are after we get them cupelled. All right, guys, here's our 3 samples. This was the 5 minutes in, 30 minutes in, and 60 minutes in. I've got them weighed, and the 60 minutes ended up with 0.115 grams. The 30 minutes, almost exactly the same at 0.114. And interestingly enough, the 5 minutes had the largest bead at 0.126 grams for precious metal. And the odd thing about this is, more or less, this sample is exactly the same as this one up here. And you can see the difference in precious metals is maybe 15-20% difference. But those are our results. And what it does look like is it doesn't really matter. I mean, you don't need to leave it in for 60 minutes or even 30 minutes. As soon as that stuff is molten and the reaction has occurred, you can pour it and recover the precious metals. All right, so if you guys have watched this long, you're probably geeking out on this as much as I am. So we're going to do one more experiment. I really want to get a larger lead button. We're using 25 grams of litharge, and so I really want to get closer to that 23 or maybe even 24 gram lead button that we should be getting, or that's the amount of lead I'm adding. Once the oxygen goes off, that's the amount of lead you should have left over. So now I'm going to experiment with the same flux ratio here of soda borax, but I'm going to add different amounts of it compared to the weight of the sulfides we're using, and see if I can increase the size of our lead button. So let me walk through our first sample, and I'll show you what I'm doing, and then I'll tell you the results at the end. All right, guys, so here's our charge. We have 100 grams of sulfides. We have about 12.5 grams of borax, 38.5 grams of soda, the same amount of litharge at 25 grams, and the same amount of niter at 25 grams. And so I've reduced essentially our fluxing components to see how little flux we can use to recover the same amount of precious metals. And I'm also going to do another one where I use 50 grams of borax and 150 grams of soda, so essentially doubling our original, and see if that makes a big difference on the amount of precious metals recovered, as well as our lead recovered. All right, guys, here's our slag. This is the stuff that only had half the amount of flux to sulfides ratio. And you can see here, it's all pretty much matte. There's a little bit of slag layer on top, but pretty much the rest is just all iron matte, which means we didn't have enough flux to our basic flux to absorb that iron matte we made, that iron sulfide. Here's the slag from the sample. We did twice as much flux to our sulfides, and this came out, actually, this is probably the nicest slag we've seen throughout the whole experiment. It's real nice and uniform. It's kind of stony in color. The one problem I did have here is because it had so much soda in it, it tended to boil. It frothed a little bit and boiled in the crucible. So that's the only drawback to this one. But now let's go take a look at our lead beads and our precious metal beads. All right, here's our two cupels. This is the one that had the less flux in it, the 1 part flux to 2 part sulfides. Our lead bead weighed 13.19 grams, and we ended up with 0.094 grams of precious metals. And I don't know if you can tell in the video, but this looks a lot real similar to that first bead we got with the borax, where it's really gold in color, and it doesn't have a lot of silver in it, it looks like. The second one, this is the one where we had the more flux to sulfide in the 2-to-1 ratio. The beads are about the same weight, so we didn't end up reducing a whole lot more lead out of our stuff, even with more flux. That was a little bit disappointing. But we ended up with a precious metal bead of 0.103. And this bead is very, very silver in color. And we didn't have any matte. So I think the takeaway here is it's really actually pretty hard to not recover most of your precious metals. The gold is easier to recover than the silver because on these with the borax here and even here, our lowest weighing beads are very, very gold in color. And so I think when you have matte, as we did with the borax, or with the other one, where we had the very small amount of flux to sulfide ratio, our beads didn't weigh very much, but they were very, very gold in color. So that tells me that when you have a matte, most of your silver or a high percentage of your silver goes into the matte, and your gold stays there as a precious metal bead in your lead collector. The other interesting part is it really didn't matter how long you left them in. the precious metal weight was about the same, more or less, across the board there. One of the interesting things I thought about this afterwards, the samples I did up here versus the samples I did here, these have significantly more gold than these. And on each one of these, I used a fresh iron rod that was a little bit larger than the ones I used here. So there may be a surface area with your iron that has some play in it here for getting out a little bit more precious metals. So that's something that we can experiment with. But on this video, I'm just going to wrap it up. We're going to call it good on this one. And then on the back side here, where we did our fluxes, it looks like as long as you create a flux or a flux recipe that when you smelt, you don't get any matte in your pour on your cone mold, then you're getting a very, very high percentage of your precious metals. And the first three here we saw matte in. This is was the boundary, but it looks like that 75% soda to 25% borax is basic enough that it dissolves the matte on a 1-to-1 ratio with sulfides and 1 part flux. You end up with a fairly good sized lead bead, and you recover most of your precious metals. So that's kind of the results of our smelting experiments again. And kind of again, to go over the whole purpose here is to figure out the most amount of precious metals we can recover with the least amount of effort, and get a crucible as full as possible so we can recover as much precious metals as possible. We're using each smelt to its full potential, so we're not having to essentially melt down 5 times the amount of flux to 1 part of our sulfides, which is just a waste of time and energy when you can actually do a 1-to-1 flux to sulfide ratio and still recover the same amount of gold. So I hope you guys enjoyed the video. Thanks for watching. If you have any questions or comments, you can find our contact information in the description below. And also check out in the description, we have some Amazon affiliate links in there. It shows you guys kind of where I buy my stuff, what to use, so you can check those out if you're getting into smelting. So thanks again for watching, and we'll see you on the next video.